Hello you lovely people. Yes, it's me with a cold. I really needed a desktop power supply for the laboratory, and I didn't want to spend money, so I went ahead and made my own. And this is the process. Be careful. Sometimes it can be painful, especially if you've just chopped a brass PCB stand off with your Dremel and then stupidly you went and picked up the hot end with your fingers. But don't worry, I still love you, Dremel. So, as I said, I really didn't want to spend any money, and I had loads of bits kicking around, loads of parts kicking around, including a switch mode power supply, a box, so I just ordered a few little pieces from eBay, including that lovely 10-turn potentiometer, and a little module that you can see there, which has got an LED display on it that gives you the ability to vary the voltage output at 3 amps from about 40 volts down to 1.5 volts. So the switch mode is quite simple. It's got a mains incomer and it's got 24 volts out on the back end of it there. One of the things that I did need to do was design some simple push buttons. So I got my special Star Trek replicator to make those for me. It wasn't a hard design, it was a couple of cylinders that fitted together, as you can see here, all done in FreeCAD, so no biggie. The replicator didn't work very well to start off with, so it needed a bit of a spank. So I got a little tip from a friend of mine, which basically involves getting some PVA glue and some water, mixing them together and creating a solution, and that sort of works really well, and the filament tends to stick to the bed much better. So that done, I now had some little switches, and those switches line up with those little micro switches that you can see on the PCB there. So push buttons, pushy, 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 and yeah, clicky, clicky. And before you know it, I had the ability to be able to press the push buttons. So it was time to start putting this thing together. So there's the module. Oh, hang on, we've just reversed. So as far as costs go, this thing cost me relatively little because I had most of the parts already. I think I mentioned that. The binding posts were about 20p each. The module was about a £5. The PCB standoffs I already had, the screws I already had, the power supply, switch mode power supply I already had. The Bourne's potentiometer, that cost about £2.95 and took a little while to arrive. That came from China. It's a made in Mexico Bourne's precision potentiometer, so I do question how precision it is, but it's certainly good enough for what I needed it for anyway. But the assembly process was really actually quite good fun, sort of putting everything together. I know it's not perfect, it's a bit dubious, but that's the way I run. So did I mention that Bourne's potentiometer? Oh, it's a beauty. Again, another little eBay purchase. So that's a I think it might even be a 20-turn potentiometer, that big blue Bourne's potentiometer there. So that big blue potentiometer replaces the little square potentiometer that you can see up in the top left hand corner. And yes indeed, that is my TS100 soldering iron, which I am still loving and using regularly. It's been a worthy investment. I don't think it was too expensive. I think it was like 40 quid. Got a little bit overzealous with the lighter here, and I burnt the cables ever so slightly, but not in a bad way. They're just ever so slightly charred. So all I needed to do was wire that potentiometer, that big potentiometer, in place of the little potentiometer, or variable resistor, whatever you want to call them. And once that was done, I'd figured out I'd wired it up the wrong way around, and I still haven't changed that, but may do at some point in the future. And then the other thing that I needed to do was get those big, fat, juicy cables, the terminal cables, get those wired in place. And I was going for big, hairy cables because I thought to myself, well, this is going to be 3 amps. I don't want, any excuse of sort of voltage drop or current drop taking place. To be honest, I totally over-engineered it with these big fat cables. Really didn't need quite such big fat hairy cables. But learned my lesson. Again, I went to try and heat shrink these in place, and the heat shrink wouldn't fit on. I ended up having to cut extra strands out of the cables in order to make them fit inside the screw terminals. Yeah, really shouldn't have bothered with this really big thick cable. It was just a bit of an annoyance. In fact, in the end, I took some little bit of mains cable outside of one of those mains cables that you've just seen me wire into the mains incomer on the front of that switch mode power supply. So let's have a look. Is the switch mode power supply functioning? Obviously, case is open here. There are mains voltages kicking around there. Need to be a little bit careful. The switch mode has got standoffs underneath it as well, so it doesn't actually touch the aluminium box. The aluminium box is also earthed. I have made a point of making that happen. So if anything does go wrong and you get live or neutral connected to it, hopefully it'll trip the switch. And oh my goodness, look at that! Boom! It's all been put together, and there's the screwdriver of knowledge, just whacking a couple of screws in there. So the question is, does it work? So let's have a look at the output of this bad boy. Can you read that display? Okay, so yes, there you go. You can see it. You can see it adjusting. So the button on the left there turns the display on and off. The button on the right switches between the voltage input to the module and the voltage output of the module. So at the back end of the system here, then I'm just going to do some tests. So sorry about the reflections. Yeah, you can see me adjusting this now. I'm going to take it up to 15 volts on the DVM. And then if we look at the LED display, it says a 15.4 volts. So the LED display is 0.4 volts high. So what I'm going to do is connect up the oscilloscope. By the way, that scrolling, what looks like a scrolling LED display, again, is down to camera shutter speed and the fact that those LEDs are being pulse width modulation driven. So let's go ahead and use my lovely new, old but new to me oscilloscope. Look at that, bang! 5 volts per division, 3 divisions, total 15 volts, DC coupled waveform on channel 1. Absolutely beautiful. 15 volts, 1, 2, 3 divisions. Well done, Howard, good job. Yeah, you can do it in as many places as you like and it's still going to read 15 volts. Anyway, I'm glad I left that in, that made me chuckle. So the next mission was to start to have a look at the output of the system. So what I wanted to do was switch to AC coupling, get rid of that DC offset, and bias it around the center there, turn the sensitivity of the scope right up, and then let's have a look and see if we can find the switching frequency. And yes, indeed, we can find the switching frequency, and we can see that the peaks from that switching frequency are all of about 20 millivolts, so not too bad at all, and the frequency is about 50 kilohertz, which is about right. So to be honest, that's not horrible. It's sort of standard for one of these little switch mode power supplies. I got rid of that frosted translucent glass and actually put some decent see-through plastic in place, and so this is what the final unit looks like now. I still need to change the direction of control for the variable potentiometer, so that when you rotate clockwise the voltage goes up. And I also need to change around those two terminals and the voltages and the voltage output, so the red is on the right and the black is on the left, positive on the right, you know, sort of standard procedure really. Anyway, this unit is going to be very useful in the lab going forwards. If you've enjoyed this video, please don't hesitate to give it a good old thumbs up. If you've got any comments and suggestions on how this should have been done, no, actually forget that. Please say nice things in the comments section down below. I'm just kidding. You know what? Just, yeah, have a go if you want to have a go. And more importantly, don't forget to subscribe.